studied rammed earth this semester. This really started out with the ambition we knew we were going to build something big at the end, and then we went with Professor Wade, kind of treated him as our client sort of, to see what we were going to make, and we ended up making this bench out of it. But there was a long, grueling process from the beginning of the semester until now.
So kind of the first thing that we started off doing was soil testing around here in Lubbock. Also trying to figure out kind of what type of soil is actually here in Lubbock to see if it's even viable for using rammed earth here. Kind of the main component that we were looking for was the clay content. Looking for an average about 20% clay content within the soil, and by soil we mean about 18 to like 2 feet below that actual ground, because anything above that will have organics in it. And by organics we mean roots, leaves, anything like that, and that can actually be degradable, as you can kind of see in one of our early test subjects or test cylinders. It actually breaks down the build over time. This turned out beautiful when we first did it. It had the right clay content and everything, and it was a raw design, which means that it didn't have any other binders added to it, but since it did have organics in it, it started breaking down.
And that kind of pushed us to another direction. We started going a little deeper. We started looking at soils that we knew we were going to have many organics in them, but then we found that the size of the granules themselves really came into a factor. We have a very silty soil here in Lubbock, and meaning very fine grain soil. Great for agriculture, not so great for having a very durable, long-lasting rammed earth build. And we could prove that because we were able to make some cylinders, such as this one, where we had really fine sand and very nice textures, very smooth surfaces, but the edges were, no matter what we do, they would always be brittle. The only way we could compensate for that was adding in cement, and that was against our #1 goal, which was just to do raw rammed earth. Which brings me to this, actually.
Yeah.
Well, we did a few other things here too.
So then after we started doing that, we were trying to stick to a lower cement content in it. Most of our test cylinders that we actually did were just about a 5% in aggregate that we were kind of commonly using, just to see if it actually show up, was granite. It didn't really show up as much as we wanted to, unless we added like a ton of it, and it just kind of seemed to backfire a little bit. So instead we started doing kind of these color tests. These two looking more specifically at like a darker charcoal color, because when you do add the cement, it actually grays out the soil a lot. And then more of kind of the extreme of a terracotta color, and just like really pouring it in to see how much we could actually get out of it. And that these kind of were all our test cylinders, and this bad boy was kind of our first big build. It was actually 3 of these blocks about this size, with different
all kinds of different
different mixtures for each block. And when we took it out of the formwork, it was standing perfectly fine, but then we tried to tip it over, and of course it acted like we thought it would break and shear. And because this is such a compressive type of structure, it only deals well with compression. So when it acts in shear, it does tend to break.
Yep, and pretty much any other force for that matter, tension included. Anytime you have any force that's not a gravity load, you're going to experience some form of shear or undesired action within this material. So we went with, learning from that, we went with reinforcing this with steel rebar, just like you would with concrete. We have 2 quarter half-inch rods going straight up vertically through this structure, and that's keeping all of these 3 layers together and keeping them from lateral forces. keeping that from shearing away. So this will stand test of time. Now, we did experience some problems.
Mostly, and to kind of go on that a little bit too, for helping reinforcement, we also started looking at weatherproofing a little bit more. We were trying to look at, actually in this test cylinder, as 100% the liquid in it that we added to it was acryl. It's a sealer that is commonly used in concrete as well, but then we also had a cement sealer, a powder form sealer, that we eventually used in this as well, just to have that extra durability, because it kind of creates a finer solid edge along this, and it's not as brittle as the other ones that we were finding because of that sealer. And then finally, after we did our testing, tested out different like variations of our formula that we were going to go for, we kind of finished this.
Yeah, so let's talk about this for a second. This is how much do you think this thing weighs?
Oh, I don't know.
I know we gathered about 1,800 pounds of dirt. We only used probably about a little more than half. And that's from around here. We chose a specific location for that soil that we knew worked well from our tests. And then we assembled a formwork, which for the most part held together. It was in one corner where we experienced a bit of an anomaly that caused this fracturing down here. And that's really important for us to look at, because now we're considering other options for how to repair these areas and then seal off so that they will stand the test of time as the rest of the build will. The rest of the build went well. I don't think we saw any other major concerns as far as cracks or anything like that, other than this corner, which we are quite happy with considering. We used a pneumatic tamper with a industrial size air compressor and a lot of dirt, water, acryl, granite, gravel, and cement.
How's the scatter?
Good. It clumped up nicely, so it's basically there.
Got to bump up against the edge now.